So next property of the log, I'm not sure about the number, whether it is 3 or 4 or 5 maybe. So the next property is, if there is a x to the r, this r is the exponent of x only, not the whole log, okay? If there is a log of x to the r base a, then you can move that r to the front. That exponent goes to the front, and then you can write r times log of x with base a, okay? So let's see an example. In this example, you have log of 8 with base 2. So can you write that 8 with some exponent of some number? So you can write log of 8 is 2 to the third with base 2, right? So you can pull that 3 to the front. So it will be like 3 log of 2 with base 2. But what is log of 2 with base 2? It is 1 by property number 1, right? So if they have the same number here and here, then it is 1. So this thing is 1, this is 1. So the final answer is 3 times 1, that is 3. So log of 8 with base 2 is 3. The next thing we want to do is, you want to combine these two logs, okay? So log of x to the third with base a, log of x to the fifth with base a. So there are two ways to do that. One way is, you can apply formula number 3, that is, you add the two logs, meaning that log of base a x cubed times x to the fifth, that will be x to the 8th, right? And so you can move that 8 out, so it will be like 8 log x base x with base a. The other method is, you move that 3 immediately, it is like 3 log of x with base a, because you can move that 3 to the front. Similarly, plus 5, you can move that exponent 5 log of x with base a, okay? So it is like 3 oranges plus 5 oranges, because log x to the a, because both of them have log x to the a, so log x to the a, right? So what you can do is like 3 plus 5, factor out log of x with base a, okay? Log x with base a is factored out, so it is like basically 8 log of x with base a. You can do this way too, okay? Next one is example 3. Solve log x to the 7th with base 2 equals to 14. So how do I solve this? So use that rule. You can move that 7 out, so it is like 7 log of x with base 2 equals to 14. Now divide both sides by 7. So if you divide by 7, what do you get? You got log of x with base 2 equals to 2, because when you divide 14 by 7, it will be like 2. Now you want to solve for x. So how do you get rid of log? You write 2 base to the other side equals to x. So x equals to 4. And does that x equals to 4 make sense or not? Yes. Because if you replace x by 4, you will get 4 to the 7. So that will be a positive number, right? So there is another way to do that. You can just get rid of log immediately from here. It will be like x to the 7th equals to 2 to the 14th, like that, okay? X to the 7th will be 2 to the 14th, and then you can take the 7th root on both sides. You will get x equals to 4. Next one is this one. Again, there is an exponent. You can pull that exponent out. So 3 log of base 2 x plus 1 equals to 6. Now divide both sides by 3, because you want to solve for x. So first of all, get rid of 3, then get rid of log, and then you will solve for x. Divide by 3, what do you get? You got log, you cancel that 3 and 3, log base 2 x plus 1 equals to 2. Make sense? The next thing you want to do is, you want to get rid of log. So how do I get rid of log? You do 2 to the other side. So it is like 2 to the other side, the base to the other side equals to x plus 1, right? And then this is basically 4 equals to x plus 1. Subtract 1, you get x equals to 3. Does this make sense here? 3 plus 1 is 4 to the third. That is positive. Log of positive is okay. So x equals to 3 is the right answer. Okay. Now let's do the last example here. You have log of x with base a, log of x minus 2 with base a. They have the same base, equals to log of 3, basically 3 times log of 2 with base a. So you can combine these two logs. How do you combine that? You write log base a x times x minus 2, you multiply. When you add log, you multiply those quantities there, right? Equals to so there is 3, okay, 3 log 2 with base a. But if you want to compare two logs, since this log doesn't have any number before that, we want that log without number before the log. So what you can do is log of 2 to the third with base a. Make sense? So see, there is log base a, there is log base a, there is nothing before log, there is nothing before log. So you can think of these cancelling those to log base a. So what do you get? You got x squared minus twice x, because x distribute x times x is x squared, x times negative 2 is negative 2x, equals to 2 to the third is 8. Okay, so one thing that you notice here is it is not like you cannot cancel here. What you can do is you can think of this like, if this is like log of x equals to log of y with the same base, then you can write x equals to y. This is the fact what we use here, but you can think of like canceling those, right? So if they are the same, then the x must be equals to y. That's what we use here. Okay, now how do I solve this? This is quadratic. To solve a quadratic equation, what you do is you make the right hand side 0, right? So subtract 8 on both sides, so you get x squared minus 2x minus 8 equals to 0. So how do you solve this? So x and then x, what are the two numbers whose product is negative 8 and sum is negative 2? That is negative 4 and positive 2. That's right. So if you solve this, what do you get? If you solve the first one, you get x equals to 4. If you solve the second one, you get x equals to negative 2, right? So which one makes sense? We need to check that. Let's plug in x equals to 4. If you plug in x equals to 4, you get log 4. That's fine because it is positive. Log 4 minus 2 is 2. That is also fine. So x equals to 4 is good. How about x equals to negative 2? It is not, because when you plug in x equals to negative 2 here, you'll get log negative 2. That's not good, right? So because log is not defined at negative 2. So x equals negative 2 is not the good answer. So x equals to 4 is the right answer for this example. All right. Okay, the final property of the log is base change formula, okay? Meaning that if you have some base and if you want to change that log into different base, we use this formula. What is happening here is log of a with base b. Here the base is b, right? And you want to change this base b into different base, say suppose c. So how do you write that? You write log of the top number with base c, that is you want to change in terms of the base c, divide by log of the bottom number with base c. That's what you want to, right? So log a with base c divided by log b with base c. That's what you do. Okay, let's see this example. Write log 8 with base 5 with base 2. So how do you write that? So log of 8 with base 5 can be written as, you want to write with base 2, right? So c is 2 here. So you can write log of 8 with base 2 divided by log of 5 with base 2. That's what the base 2 for log 8 with base 5. Okay, let's see this example 2. Write log of 7 with base 3 with base e. You want to change base 3 with base e and use calculator to find its value. Okay, so your calculator, if you have TI-83, it has only the base e, that is ln key in your calculator, and log, that is base 10. So if you have any other logarithm, you want to find the value of any base, any other base than e and 10, you'll have to use this formula to change into base e or base 10 and then use calculator to find out the value. In this example, it has base 3, so your TI-83 cannot calculate that. But if you have TI-84 though, you can use math and then scroll down until you hit log base, and if you press that, you can enter that 7 and 3 there. But for TI-83, you will have to change the base and then get the value. Okay, so basically here log of 7 with base 3. If you want to write this with base e, how do you write that? Use that formula, is log of 7 with base e divided by log of 3 with base e. Right, this is basically natural log of 7 over natural log of 3, because log base e is also written as ln. Okay, now you use calculator. Write down natural log of 7 and divide by natural log of 3. So if you want to find the separate values, you don't have to. You can just divide it using calculator and you will get like 1.7712. That's what you will get if you use calculator for this. Alright, and the final example on this is solve this for x using log and change the base to base 10. So how do you write this using log? Do that first. So you will have different base there and change that base to base 10 and then use calculator to find out the value. That's what you want to do. Okay, so let's write down this. So the given thing is 2 to the x equals to 5. So how do you write this using log? So the exponent equals to log of the other side. The base goes to the base. Okay, so how do you write this? So this has base 2 though, right? And you want to write this with using base 10. How do you write using base 10? So you do log of the top number with base 10. That's what you want. And log of the bottom number with base 10. That's what you do, right? You can use calculator. This is basically same as log 5 over log 2, because if the base is 10, you don't have to write anything there. It is just, if you just write log, the calculator understand that the base is 10. Okay, so if you use calculator to find out this value, you will get 2.32. That will be the final answer for this question. All right, guys.